In this video, we're going to learn the following. Number 1, formation of ions. Number 2, types of ions and associated energies. Number 3, valency, radicals, and oxidation numbers. And number 4, chemical formula. Let's start with the first one, formation of ions. For example, sodium ion. Consider sodium atom with atomic number 11. It has an electron arrangement of 2, 8, 1, and the outermost energy level has only 1 electron. And since it has less than 4 electrons in the outermost energy level, it forms its ion by losing that 1 electron. Just like what you can see in the diagram, the sodium atom, the innermost energy level has 2 electrons, the second energy level has 8 electrons, and the outer one has 1 electron. It loses that 1 electron to form a sodium ion with a charge of positive, and now has 2 energy levels instead of 3 that we're able to see in the sodium atom. Sodium can acquire a stable configuration of 2,8 by losing 1 electron or 2,8,8 by gaining 7 electrons. But this depends on the energy. So, it is easier to lose 1 electron than it is to gain 7 electrons. Therefore, the resulting sodium particle will have only 10 electrons while the nucleus still has 11 protons. So the 10 negative charges and 11 positive charges give a resulting particle with a net positive charge of 1. So the sodium ion is written as Na+. Consider another example of the chloride ion that is formed from a chlorine atom. Atomic number is 7, electron arrangement is 287, meaning the outermost energy level has 7 electrons. It therefore forms its ion by gaining 1 electron in the outermost energy level. So consider the chlorine atom. The innermost energy level has got 2 electrons. The second energy level has got 8 electrons, and the outermost has got 7 electrons. So to complete that to 8, it requires to gain 1 electron to complete 2, 8, 8. So you can see on the diagram the gained electron. Then the net positive charge is negative, showing that 1 extra electron has been gained, and the particle formed is a chloride ion with a configuration of 2, 8, 8. So the explanation is here. Chlorine atom can either lose 7 or gain 1, but it is easier for it to gain 1 electron because it requires less energy than it is to lose 7 electrons. Therefore, a chlorine atom with 17 electrons and 17 protons will gain an electron and have 18 electrons, but the protons still remain 17. So this is what results into a net negative charge 1. So the ion, as I've said, is a chloride ion. Now consider the magnesium ion. So we have the magnesium atom with 2H2. It will lose 2 electrons to form a magnesium ion with 2, 8. Next is on the types of ions and the associated energies. So we have 2 types of ions. One is the cations, which are the positively charged ions formed when atoms lose electrons, and then anions, which are the negatively charged ions. Ionization energy is defined as the energy required to remove an electron from the outermost energy level of an atom in the gaseous state, and applies when atoms lose electrons. Then there is the electron affinity, is the energy lost by an atom when it gains an electron into the outermost energy level. So let's look at valency, radicals, and oxidation numbers. Starting with valency, is the number of electrons an atom loses or gains during a chemical reaction. So we have a number of them listed in the table below. So it also refers to the combining power of an element. For example, we look at element sulfur with electron arrangement of 286. So sulfur forms its ion by gaining 2 electrons. Therefore, its valency is 2. So the others will follow. If you look at sodium, loses 1 electron, and therefore its valency is 1. What about radicals? So these are a group of atoms with a net charge that exist and react as a unit during a chemical reaction. So the valency is the same as the value of its charge. We have the examples there. Ammonium ion with a positive charge has got a valency of 1. Hydroxide ion with a charge of single negative has a valency of 1. You go to others, for example, the carbonate with 2 negative, the valency is 2. And you go to the phosphate with a charge of 3 negative, the valency is 3. Following now is the oxidation number. So when an atom loses or gains an electron, the charge on the resulting ion is also known as the oxidation number of that element. The only difference between oxidation number and charge is that in the oxidation number, the value is written after the sign, or you can say the sign is written before the number, while in the charge, the sign comes after the number, and you will see that P3 negative, that is a charge. Some elements have variable valencies. So in this case, when the valencies vary, that valency is specified in the name. For example, copper 2 ion has got a valency 2. Iron 2 ion has valency 2. And we can see some examples here. Magnesium 2 has valency 2 and oxidation number of 2. But when you go down where we have magnesium, which is not an ion, with no charge, the oxidation number is 0. So you can pause the video at this moment and then try completing the table. Let us now look at the chemical formula. So chemical formula is the shorthand notation using chemical symbols and numerical subscripts to represent the composition of substances in a compound. And an example of sodium chloride is given there. But we need to know the valencies and the correct symbols of the elements before we can be able to write the correct chemical formula. Consider an element X with a valency small x and element Y with the valency small y. So the formula of the compound formed when X and Y react can be written as follows. So element X with valency X and then element Y with valency Y, there will be an exchange of their valencies. The valency of X goes to Y, and then the valency of Y comes to X. So that is the ratio in which they are going to combine. So the formula is XY, YX as shown there. Let's look at examples of sodium chloride, magnesium chloride. So starting with sodium chloride. So sodium has valency 1. Chlorine also has a valency of 1. How therefore do they combine to form sodium chloride? So look at what we have next. They both have valency 1, 1, which they exchange, but it just remains 1, 1. So we don't normally write if it is 1, 1. So that is the formula of sodium chloride. Now consider magnesium chloride. Magnesium with valency 2, chlorine valency 1. There will be exchange of the valencies. 1 goes to magnesium and 2 goes to chlorine. And that is the formula of magnesium chloride. Magnesium nitrate. Magnesium 2, nitrate 1. Now they exchange the valencies, as you can see. Then we end up with magnesium nitrate. When there are elements with variable valencies, like we say copper 2 oxide, the valency of copper is 2. Iron 2 sulfate, valency of iron is 2. But these are specified because we also have iron 3 sulfate, where the valency of iron is now 3. We can also have copper 1 oxide, where the valency of copper is 1. So variable valencies are always stated in the name of the corresponding compound. You can practice with the following that are given here.